So hello guys, welcome on this talk. Today I would like to talk about Typesafe arguments in Jetpack Navigation. I'm Jan Škrášek, I work here in kiwi.com, and actually we created a library. So this talk is somehow about the library and the reason why we have created it. So first of all, I would like to talk about those requirements, why we have created the library, what we need, what's the reason we need it. Then obviously the library itself, it's called Navigation Compose Typed. Later I will show you a few tricks with the library or what we are doing in it. And last but not least, I will show you alternative usages because the library is not somehow strict in a way how to use it. So you can choose another type how to use it. So requirements of the navigation stack itself. You know, we have Compose, and this is the new UI toolkit in Android. And obviously the navigation stack is somehow connected deeply with the Android itself, or at least we want the navigation stack to be connected to the Android. So we need state restoration when the system kills the app, you know. When you return to the app, you need to stay on the same page, on the same screen. Similarly, bottom sheets are quite native to Android, so we need our navigation library to support them. And it's the same probably with the material transition. We need those navigation animations to be nice and up to date with the latest spec. So this should be supported as well. And the main topic here, why we are today, is the arguments type safety. So this is somehow missing, and we will cover this. And I will be also talking about compilation speed and deep link backstack handling, because these are quite important things for us as well. I won't cover multi-platform, not because it's not important, but because we don't need it. This is not our requirement, at least for now in Kiwi. So let's get into it. This is an example or official sample how to use library Jetpack Navigation Compose. This is the official library from Google. So when you want to do navigation in Compose itself, they suggest to create this kind of destination object holding all those routes. They are practically some part of URL. The domain is missing, but the path is there. You can see that if there is argument or some input for the destination, you should put the email placeholder into the route. Then you will use the nav host from the Jetpack Navigation. You will define the start destination and define the actual destination, how to render them. So here is the composable for the welcome route. And the welcome screen or composable is called here. And it has some callbacks, which are tackling the navigation to other screens. And you can see that you are using, once again, some part of the URL. So there is sign in and there is a sign up, and the argument is somehow converted to the email. Obviously, this is not optimal in a way that there's some kind of repetition. Yeah, you can do some abstraction, but it's up to you. It's not in the library itself. What's more, the arguments as the email has to be somehow converted to the URL itself. This way, there is no escaping. So if the string contains some illegal character for the URL, it will break. And you have to also think about the ordering of those arguments. If you would have more than email, you would have to know that email is the first, and then there is the next one. So this is our requirement. We want to make this better. This is not optimal for us, or at least for the app how we currently have. Maybe for few screens, but it doesn't scale. Next is the compilation speed. There are other libraries doing the navigation stack for you. They can be runtime only, so basically there is no slowdown during the compilation. Those libraries may work quite well. We have the issue with the Jetpack Navigation Compose, but it doesn't mean that those other libraries are not doing this well. The Typesafe navigation. There are extensions to the Jetpack Navigation. Those are those KSP-based Kotlin symbol processor-based. Those libraries are using another task during the Gradle build to generate something for you. Those generated classes will help you with the type safety, and this way they will fix the Jetpack Navigation Compose. The last kind of way how to affect the compilation speed is using a Kotlin compiler plugin. For example, this library is using parcelable plugin to generate some parcelable implementation for you. As you can guess, those runtime are not an issue for us. Kotlin compiler plugin is, let's say, acceptable, and KSP is probably not acceptable in a way that half of our modules has some UI, and it means that those modules have to use the KSP. It would be a significant slowdown in the summer. The third topic I would like to cover in our requirement part is the deep link handling. So in Android, you have the navigation up button, which is kinda in the top up bar. It's the image on the left. And then you have the back gesture or the back, nowadays, software button, which is on the bottom. That's the arrow on the left. So those buttons behave almost identically all the time. So when you are in the same app task, they behave the same. But then there is the difference when you are opening your app from a deep link. Basically, the deep link should be opened in the task when you are starting, when you are clicking the link. And then there should be difference. The back button should take you back to the original screen when you have clicked the link to the original app. And the navigate up button should recreate probably the previous screen in your very own app. So this is a difference, and the library should cover this. Obviously, this is documented on the android.com. So let's take a look at this video. So here we are clicking on a link in Keep app, and we are opening GitHub, and we are opening files of pull request. And when we are doing the back gesture, we are not going back to the Keep app, but we are going to the pull request detail. And this is unexpected for the user. To be honest, this fits those rules because they are opening the GitHub app in the original GitHub task. It's not in the original, or it's the GitHub is open in its own task. It's not open in the original Keep task. But still, user don't expect this, and we need to cover this. And not all libraries are doing it. So if you are opening deep link, some libraries will offer you this. Let's tell us what is the artificial backstack. So when there is a deep link to post detail screen, you can say, okay, this post detail screen has the backstack that before it, there is the post list screen, and then there is the home. The issue is that that's all. And the differentiation between navigating up and navigating back has to be handled by you. And that's our burden you have to tackle. So that's our last requirement. So the question, or the first question was, can we use some extension over Jetpack Navigation Compose, or should we pick some solution based on new shiny library and don't care about Jetpack Navigation at all? So we did an evaluation, and this screenshot is missing library names. It's on purpose because those answers may not be correct, or this was done 6 months ago. It may not be true right now. But as you can see, there's a lot to cover, and you should evaluate what fits your use case. We did so. So we have ended up with custom solution, which was based on Jetpack Navigation Compose. Don't remember to ask some question on Slido. So our custom solution could solve this issue because this is the only issue we have with Jetpack Navigation Compose. It's the repetition, it's the argument processing, and the type safety of those arguments. And the ideal solution could look like this. We would, instead of defining those roots, we would define those objects or data classes. The email is suddenly type, it's a string, or it can be a value class ideally. And when you are navigating to some other place, you would just create the instance of the destination itself, and the nav control would take the instance of the destination and would navigate to the final place. So we have seen that we could utilize the Kotlin compiler plugin, which already exists. That is the parcelable implementation. That would be good because we wouldn't have to implement new Kotlin compiler plugin from scratch. And the trivial implementation would be obviously using destinations which are a parcelable type. Then we would use the annotation then the Kotlin compiler plugin would automatically generate all those metadata needed for in the runtime. And the processing or the metadata would be used later. So when you will pass the destination itself, we will take the destination, create a parcel from it. That's basically a byte array. We will encode the byte array to base 64 to be somehow valid for the URL. We would use reflection to take the destination name, and that's it. And we would navigate to the final URL. So do you think does it work? Actually, it does. So simple, and it does work. But there's a catch, obviously. And the catch is connected to the deep link handling and backstack recreation. In Jetpack Compose, when you are navigating to a deep link, you are creating or instantiating just the last deep link destination you need to show. So, for example, when we have an app which has list of books, the book detail, and then the list of chapters in the book, and navigating to the list of chapters, only the last destination would be created. And then when a user navigates up, you need to recreate the backstack, right? But how to recreate backstack when there is an argument on the way? Where to get the ID? So Jetpack Navigation Compose does a smart thing, let's say it this way, and it reuses the ID from the book chapters destination. From the URL, it sees the parameters the same name, so let's use the value for the recreated book ID. So in our trivial implementation, it would look like this. You would have those URLs, then there would be only one args, which would be base 64. And when we would navigate from the deep link destination to the previous one, booking detail, we would need to recreate it with the ID. But since we have just one args, and it can consist from multiple values, this wouldn't work for Jetpack Compose. Jetpack Compose wouldn't be able to guess the right value for the book detail destination. So we need to decompose the destination object to particular values in it, have the IDs and others parameters separate in the URL itself. So parsable implementation, or this trivial implementation with parsable, doesn't work. So the question is how to utilize the parsable implementation to know all those property names and retrieve those values and be able to create those URLs which would work with Jetpack Compose. And the answer is you cannot. Parsable is not able to do this for you. But there's the answer. Kotlin Serialization is definitely the right tool for this. So this is slowly becoming our library, because our library is based on the Kotlin Serialization. So we have the same kind of destination definitions, and we just switch the parsable for the serializable annotation that tells the Kotlin Serialization plugin to generate all those metadata for you during the compile phase. You will still use the common nav host, put composable in it for the welcome screen. You can see there is a create root pattern. We will cover it, and the usage in those callbacks is the same as with the parsable implementation. Just create the instance of it and navigate. So let's take a look how to use those metadata to be able to create a root pattern for this nav host. So this function is generic, obviously, and you can retrieve the serializer. And the serializer object is the object which holds all those metadata for you. So you can read the object name, and this way you will get the actual name you have used in your code, and it doesn't matter that the object is somehow modified or renamed by ProGuard or R8. If there are no arguments or no parameters in the object, you will just return this name, because this will be the only part in the URL. If there are some elements, you can iterate over them, get their name, get their types or those metadata about them. We have snaf type optional function which reads those metadata and decides if the argument is in the end optional. If the argument is optional, we will append the argument as a query parameter. Remember, we are doing the pattern. We are not constructing the final URL with values. We are just creating a pattern. So this way we will create the pattern for the URL, and that's it. We will return it and you have a string which represent the destinations. This all happens in runtime, but those metadata are pre-compiled or prepared for you during the compile time. So let's take a look how to navigate, how to process the .navigate method. Once again, you have the actual destination with actual values, and you need to somehow convert them to the final URL. So we are using a builder here to be safe, not to construct this ourselves. It is much easier to do the pattern, but here we have to be careful because of those values. And we will utilize some custom URL encoder we'll see later. And the URL encoder takes the serializer with those metadata. Oh, there should be probably the serializer function call here. And the actual destination we want to convert. To create your own encoder, you can inherit from abstract encoder. And basically, it will allow you to override all those methods. So when there is an int in the destination object, it will call the encode int. You will take the value and somehow append it or add it to the URL object, URL builder object. So once again, you are using some metadata if the parameter is optional or not. And you are adding it either as query parameter or path value. So we have talked about encoding, that's the navigate method. But the question is how to read those values, how to decode them. And that's here in the sign-in destination. Basically, we are getting backstack entry. The backstack entry contains a bundle, that's Android type, you probably know it. And bundle is basically a map, key value map which is delivering you those values. So we need to convert this map to the actual destination object, because that's kind of object which gives us quite nice interface. It checks the necessary properties if you have them. If you are not able to construct this object, you have obviously an issue. So let's take a look at the decoding. So we are creating our own decoder. Once again, we are inheriting from abstract decoder. That's a class in Kotlin serialization library. The input is the bundle, that's the map, key value map. And once again, we will just override a few functions which will tell us what to do. So when the destination object needs an int, it will call decode int. We will use the element name to get the string from the bundle and convert it to int. That's all. So the overall composable destination could look like this. That's not only the root, which is the pattern, but you have to specify also a list of those arguments. That's another kind of metadata for Jetpack Navigation Compose. And the create of arguments is using all the same metadata we were using in create root pattern to construct those objects. Decode arguments we have covered on the previous slide. So this is it. And because it's quite verbose to repeat those create root pattern for every destination, to create enough arguments, we have shortcut, which is basically a generic composable. You will just pass the destination type, and the dis in the lambda is the destination object itself, so you can read the email from it and just pass it to the sign-in screen. So let's talk about some implementation tricks. And the first one is nested structures. So since we are using Kotlin serialization, we can be somehow powered by it in a way that even nested classes are supported, not only some simple strings or primitive types, but you can use a nested class. The only requirement is to make the nested class also a serializable type. So this way, we can do it, but what's important, we don't care about those nested structures. So in the end, when there's a nested class, we will just fall back to JSON, because we need just those top level properties to be reused for those deep link scenarios, and those nested objects we don't care. So if there is something more complex, we will fall back to JSON and don't care about it at all. Obviously, this example is properly encoded. It's just decoded for you to see that there is a JSON object. Another trick is kind of way how we operate with optional arguments or arguments itself. When there's optional argument, we will just append it at the end of URL as query parameter. You know, query parameters, they don't maintain an order. It doesn't matter if they are first or second. But when the value is not optional, we are utilizing the pattern Jetpack Compose has it, Jetpack Navigation has in it, and we are putting those values inside the path, using them as path segment placeholders and values. But there is a catch, and the catch is the string, because the string can be an empty value, and all those URLs will end up in this kind of illegal way. So from this reason, we are always converting string parameters as an optional one and appending them as a query parameter. So that's all from tricks, and let's go to alternative usage patterns. This is the official documentation how to use it. So basically you have those composable generic shortcuts, and you can just call your composable functions in the Lambda. But sometimes there is another type of destination which is not in Jetpack Navigation itself, and it may be the bottom sheet, which is in some accompanies library or other materials libraries. So we should cover it and separate it somehow, but it's not so easy in a way that you would have multiple modules and multiple libraries, dependencies. Probably majority of them are unstable right now. So instead of it, we are providing some public API, which can you utilize to write your own abstraction over it. So for bottom sheet, you will just use those 4 public functions to create root pattern, nav arguments, decode arguments, and you are good to go with any other library for Jetpack Compose itself. This is probably most used, at least in kiwi.com, and it's documented in the documentation, kind of how to use the library itself. You will define a sealed interface of your destinations. It will implement or at least inherit the required destination interface, and you will make them serializable. Then in the nav host, you will use those generic composable functions to define your destinations, and you're good to go. But it may be verbose, or you may want to use something else. For example, you have a modularized app, and you cannot put all those destinations into single file or single module to have them in sealed interface. So yeah, this is not required to do. You can omit the sealed interface. You can define those destinations separately. And what's more, you don't have to use those composable calls in the nav host itself. You can take those destination definitions, put them to the, or take the composable functions and put them to the destinations object. This way you will wire those email to email in a different place than in the nav host, and in the nav host you will be able to just call the content function on the destination object. Obviously, you have to still pass some external dependencies like the nav controller, but you can see that the definition of the nav host is much concise, is shorter, and this way you can have quite nice overview of what is the app structure or at least the module structure, and you have multiple destinations. So that's it. Our library is open source. It's called Navigation Compose Type. As you can see, we have fixed the arguments Typesafe. They are our main issue with the Jetpack itself. We are using Kotlin compiler plugin, and most importantly, it's not our plugin, so we don't have to take care of it, and it will work. Basically, it's from JetBrains. There is the up and back support. This is good. The Jetpack Navigation Compose itself is not a multi-platform library, but if it would be a multi-platform library, we could separate it, because Kotlin X serialization is also a multi-platform solution. So we are not wired to some parsable. API is simple. You can integrate it gradually, so you don't have to rewrite the whole app advanced. You can just rewrite single destination and navigate through this object and extensions. And I would say it's good that we are based on something which is related to Google or Jetpack, because we expect Google to deliver new features as a first. For example, Android 14, we expect predictive bag handling, right? Those fancy animations when you are switching those destinations. So hopefully they will support it, and thanks to it, we will have it too. So that's all. Thank you for your attention, and feel free to ask some questions.